So today we're going to do a regioselective nitration. We're going to be taking a little bit of concentrated nitric acid and concentrated sulfuric acid, mixing them together, creating NO2+, which is going to act as an electrophile, for our methyl benzoate, which is going to act as the nucleophile. The way that we're going to make sure that we do this carefully and control it thermally is to do pretty much everything on ice. And that will enhance the safety of the whole reaction and kind of slow it from happening way too fast. These are really concentrated chemicals and will react with a lot of enthalpy, and so you want to be extra careful at every step and make sure you're not actually going to hurt or damage or affect anybody in the workspace nearby. You want to be very careful about every addition and think about it before you do it twice. That's very important when you're working with concentrated materials like we are today, especially oxidizing agents like nitric acid. So what I'm going to do first is I'm going to pipette the sulfuric acid into this flask using this graduated pipette to make sure I get exactly 3 milliliters. This one's not working. In order to make sure that this doesn't react, we're going to use a glass pipette. This is going to be in excess anyways, this sulfuric acid. So I'm just going to eyeball it and try to get as close to 3 milliliters as I possibly can. I've got some experience using these, and they usually are pretty consistent. About 2 milliliters right there. Okay. You want to be very careful with where you put this pipette when you're done, because if you actually drip any of it on the paper will start to oxidize. This stuff is nasty. Very, very concentrated and corrosive. All right, so I'm gonna put this back in the ice bath just to make sure it's safe. Now I'm gonna take one of these pipettes and transfer exactly 1.3 milliliters of the methyl benzoate into that sulfuric acid. Also, don't forget where you put your sulfuric acid pipettes. You want to make sure you dispose of them carefully. Rinse them with water first as well. So the methyl benzoate can either be measured with a small graduated cylinder or one of these graduated pipettes. We're going to want 1.3 milliliters, so it's just going to be a little bit past the 4 there. And we're going to allow this to begin to cool by preparing an ice bath. It's very important when you do any kind of ice bath that you add water to it, because it'll create much better contact with the actual reagents that are in the flask and better cooling capacity. You also want to be aware of whether or not your reaction is water sensitive and make precautions to prevent any water from getting into your reaction in case something weird happens. So I'm just going to get this stirring. This methyl benzoate automatically is beginning to smell, and that's just the compound itself. So if you are sensitive to fumes, you might want to work in the hood with this stuff. But it kind of smells a little bit minty, almost like spearmint gum. It's a little ester. Esters are always nice and smelly. So next, once we have this cooling down, we're going to begin the process of making the nitric acid and sulfuric acid mixture, which will prepare our electrophile for the nitration process. So what we're going to do is we're going to place this pre-cooled flask on the bench, it's nice to have everything cooled beforehand, just because this reaction is pretty exothermic. And we're going to take, keeping in mind which one is the sulfuric acid pipette, which is this one. The other pipette, place a fresh pipette tip in there, and we're going to take some nitric acid and add a milliliter to this graduated cylinder. The important thing you have is that you have a 1-to-1 ratio. So you should always just pay attention to the volume that you've added in the actual pipette. So did that get us a milliliter? We're a little shy of it. I feel pretty impressed with my ability to eyeball that. A little bit more. And then, nitric acid is actually a little scarier than sulfuric acid in my opinion. So I'm going to close this up, put it back in the ice. When it's nice and safe, grab the concentrated sulfuric acid, bring it back, and add a milliliter. Whoops. Best not to panic when you have a big bottle of this, you don't knock it over. Just let it fall to the ground. If the cap wants to leave, let it. Just gonna get rid of a little bit of that into the ice water. And then I'm gonna take a little bit more than that last one, just a smidgen. That's about a milliliter. I'm gonna add that to this flask. Now this mixture will rapidly heat up on its own, so you want to let it stay nice and cool by keeping it in an ice bath. So I'm going to use one of these pipettes for transferring this mixture slowly into this flask now that it's been cooled down. I'm going to do that over the course of about 15 minutes in order to allow the reaction to happen slowly and for it to be basically be limiting the amount of free NO2 plus that's available in solution for nitration. You don't want to overcrowd the flask, because if NO2 plus is too available, the reaction might happen twice instead of just once. You want to make sure that it's very, very sparse amounts of NO2 plus in solution. So I'm going to go clean up this pipette, which has the nitric acid mixture inside of it, and I will be right back. And then once I do that, I'm going to slowly add 1 drop every couple seconds, this mixture to the flask. So what I'm going to do next is I'm going to actually lift the flask out of the ice bath and allow it to come to room temperature. So I'm going to just pull the ice bath off, put it to the side, and let it keep stirring. And that should allow the reaction to slowly finish itself up. As the temperature increases, the reaction speed will increase very quickly. So now that it has been allowed to react with the H2SO4 HNO3 mixture, it's taken on a slightly yellow color, and that began pretty much as soon as I started adding this mixture to the flask, even when it was under the ice. I suspect that, maybe the color will change or darken, but it went from clear to yellow, and that's definitely something that you want to put in your lab notebook as a note of, oh, maybe a reaction's happening right now. So we have let this stir for 10 minutes. I just kind of took it off of the stirring, turn off the stirring right here, and we're going to throw it into about 5 grams to 10 grams of ice right here. The key is you don't want too much ice, because if you have a little bit too much ice, in fact I think I probably have a little too much, you could always add more, you're going to end up with chunks of ice in your filter, and that's no good. So you want to do this very carefully and in one swift motion, mostly because there's probably going to be a bit of a reaction when you add this concentrated acid to the mixture. So if you want to remove the stir bar now, this is a good time. Just make sure that if it's covered in acid that you keep that in mind and put it somewhere. But if you're not too worried about the stir bar ending up inside of this flask, which I'm not, you can also just throw it in there and then pick it up later in a second. When it came in contact with that ice, the solubility difference caused the product to sort of just fall right out of solution and sort of bloom out, and automatically you saw solid formation and precipitation in that product. So you try to get as much of it as you can. It's pretty sticky, so it's probably not going to come off the flask. Let's see if I can get a little bit more of it. You can always get a spatula too. So you're probably going to want to stick with a glass stirrer in this case, because if you're going to put metal in there, it's still pretty acidic, and that could potentially corrode the metal and potentially also contaminate your product, which is no good. So let me just grab a glass stirring rod. Remember that you're going to want to avoid as much of that ice being in your filter as possible. So I'll just get in the way, make things inconvenient for you. I took the liberty of taking a filter head and some filter paper and pre-weighing it so that I can just start the filter and get it going so we can filter this product and collect the mass efficiently. So what you're going to do first is you're going to make sure that your flask is, your sidearm flask is nice and stable. You don't want it to fall over or anything. You also want to make sure that everything is set carefully so that you're going to have good suction. I'm going to grab a water bottle here. Actually, there's some pre-chilled ice water. So I grabbed everything we're going to need to do this filtration. The way that you're going to want to start in this case, just because you're going to want to make sure that you keep the filter paper well adhered to the filter head, is you're going to turn on the pump. You're going to take some of the DI water and just go around the edges to make sure the suction's great on the filter paper to prevent any kind of product sliding underneath it. You're going to take your product and you're going to just carefully place as much of it in the middle of the filter paper as possible. What you're going to do next is you're going to take the pre-chilled DI water, rinse your flask, try to get as much of the product that was left over as possible. Alright, that was about 2 ml portions of the chilled DI water. It doesn't have to be exactly 2 milliliters. Some people will follow that to a T. In this case, we're just trying to make sure that we're washing the product. So depending on your filter size or a lot of other factors, some people want to follow the procedure perfectly. It doesn't matter too much because it's going to always vary depending on your yield and how effective your addition method is, the way that you're adding it to the filter head. I'm going to add about 1 milliliter of this methanol. And you're going to want to make sure you direct it onto the product because you want to be dissolving potentially any impurities. I'm going to add a little bit more than that too. You want to be dissolving those impurities that are going to be on the surface of your product. That'll also help it dry if it's a volatile solid. Now, if you're really trying to maximize your yield, and you notice you have a lot of precipitate underneath in your filtrate, you're going to want to make sure that you refilter it and allow it to precipitate, or maybe recrystallize the filtrate. For me, I'm more interested in actually maximizing purity, and so making sure that whatever's up here, the precipitate at the top of the filter, is as high quality and pure as possible, is going to give me the best melting point possible. And so once I recrystallize it in methanol, that's going to maximize the purity there as well. So we'll get to that right now. It's time to begin the recrystallization. So what I'm going to do first is I'm just going to get an initial yield of the crude product, and that's going to just require me to take this filter head, which is removable from over at the Buchner filter, and I'm going to weigh this entire thing. So I weighed the filter head plus the filter paper. I put 2 filter papers in there just to make sure we didn't lose any of the precipitate, and then also the product which is inside of here, and then we will transfer that product into this test tube for the recrystallization. The slower that you recrystallize, the better. Virtually every single time you recrystallize, you always want to avoid too much bumping, vibration, and any kind of motion, as well as temperature change that could knock everything out of solution. All right, so now I'm going to place this sample into this test tube. How are we going to do it? As carefully as possible. So you're just going to tip this to the side, give it a few taps, and try to get as much of that product into the test tube as possible. Looks like we have about a gram of material in there. I'll be able to calculate that later. And what we're going to do is we're going to add a minimal amount of methanol, because we want to make sure that once the solution cools, everything falls out again. And it's slightly warmer than room temperature, not much. I'm going to just add methanol, a couple milliliters, and see if virtually any of this appears to be dissolving. Looks like solubility is pretty low in methanol. Maybe a little of it has dissolved. Now once we heat it, that's probably going to change. So we're going to crank that thing all the way up if we can too. Remember that with any recrystallization, you can expect that if the amount of material that you have in the flask is not dissolved in this amount of methanol, then you'll get that much product at the end of the day. So the more of the methanol that you add, and the more of this that dissolves at room temperature, the less of it you're going to get back once you go back to that original room temperature. If you're trying to do both maximize purity and yield, you'll use as little methanol as possible. And recrystallize as slow as possible. We have reached the maximum temperature that this water is going to give us. Also the methanol inside of this tube is starting to boil, and that's a good sign to make sure that you're looking at whether or not you think that this is going to be the ideal amount of methanol to fully dissolve our product. Probably, if the methanol is already boiling, it's not going to really get any hotter. It's not going to take on any more of that product that we have as a crude. So add just a little bit more and see if that helps. Appears to be slowly dissolving. See if we need to add more. We want to make sure that the solution gets completely clear, as it just did, before you add or allow it to cool at all. Very, very important. You also want to make sure that it's at a proper boil, because that will be the maximum temperature for the maximum solubility, making sure there are no little pieces that could potentially salt out impure or less high quality crystals. So we will call this good. Slowly remove the water bath. Close this up. And allow this to cool. Do your best to avoid jostling this too much, because the slower and more undisturbed that this is allowed to actually cool, the better quality crystals you'll get, and the higher quality product you'll get. You want to be seeing fine needles most of the time, but it looks like because this methanol is boiling unevenly, that there's a bit of turbulence there, so I don't know how high quality we're going to get. We will see in a few minutes once this is cooled down. All right, so we've got our product. It crystallized out, and if you can see closely, it's quite crystalline, very almost like a snow globe. And they're not clumping together. They're very shiny. If you can look at them closely, that's always a good sign of quality. Shininess is what you want in any kind of product that you're interested in crystallizing. So that means that you're gonna have a lot of big flat surfaces that light are reflecting on, meaning you're forming lots of different kinds of geometric shapes that are not just a sludgy, clumpy mess. Okay, so as usual, when it comes to working with any kind of vacuum filtration apparatus, you're always going to want to flip the switch. You're going to grab the solvent you're going to be using. In this case, we're going to be using just cold methanol this time around. And we're going to take a little bit of that cold methanol, and we're going to add some of it to the filter paper to get a good seal. And once we do that, we're going to take our product and we're going to try to get as much of it in one pass as we can onto this filter. There we go. Got a big chunk of it there. So if you're looking at it and you see it starts to get smaller and smaller, it probably means that whatever solvent you're using to wash it is too soluble. You want to keep as much of your product as you can. You want to maximize your yield. So you're going to try to keep an eye on whether or not you're just flattening that pile of product, or if it's actually dissolving and going down to the bottom of the flask. Looks like there's some precipitation happening down here, but we're not too worried about it today, at least. So one thing that I also like to do is I like to take a clean spatula and I like to flatten out the product so they can dry more effectively. So like that. Start to push around the product just so it's nice and flat and even all along the surface here, and then it can dry. You'll notice if you look closely here, the product is somewhat fluffy. That's also a great sign. Not clumpy. Just like freshly packed snow. All right, time to go weigh this, and then once we weigh this, we're going to go through the other characterization steps Those will be given to you in the post-lab information, like the melting point that we obtained. This is what we're going to call probably the end of the video. So thanks for watching, and for those of you who are in the class, you're already subscribed, so don't worry about it. Anyone else who's interested, feel free to subscribe. See you around. Well, that's a bummer.
What?
Also, the graduations are starting to come off. So probably this is not, I was a little nervous putting this in there, but definitely not a good call. I'm going to throw this in the sink.
Really?
Yeah, look at it go. I'm just going to go for plus